I'm Bob Chaddock. I'm the Interim Director of Applied Research here at the National Archives. This is the first time that the National Archives we've ever had 3 of our principal investigators here at the same time. The opportunity not just to see their individual works, but to basically see the synergies and the relationships and the activities across the activities is something we've never been able to do before. It's my privilege to introduce and to reintroduce and to welcome back our 3 colleagues. For those of you that haven't previously met them, Dr. Peter Baichi is the Associate Director for Image and Spatial Data Analysis in the Institute of Computing and the Humanities at the National Center for Supercomputing Applications, a national laboratory operated by the University of Illinois. He's also he's an associate professor of electrical engineering and also of computer science at the University of Illinois. I'll share with each of you a cool fact about each of our contributors. Dr. Baichi had the privilege of presenting the first presentation of federal research results to the administration of President Obama on the day after the inauguration. You know, he was selected for his developments in terms of his tool developments, in terms of his work at NCSA, that actually we presented his work to OSTP and staff the day after the inauguration. Among all federal researchers, he was selected for that privilege. Dr. Maria Stava is an associate researcher and data archivist at the Texas Advanced Computing Center. Her work in terms of looking at the relevant case studies and the applications of visual analytics and visualization technologies to support archival processes today is recognized as one of the national science highlights of the United States in April. It's the first activity, to my knowledge, that's ever been sponsored by the National Archives that actually has been selected as a national research highlight. That's a big deal. The other piece of it, in terms of a cool fact, is that Maria's work today is actually featured in this month's Discover magazine and has also been sponsored in Futurity and some other aspects where the recognition of the contributions of her work towards innovation puts her at that status. And then thirdly, my colleague, Dr. William Underwood, from the Georgia Institute of Technology, Georgia Tech Research Institute, is long recognized as a principal investigator in the area of decision tools, tools that basically contribute to decisions involving information and digital records. What is notable about Bill is also, for some of you may be aware, but earlier this year, Bill was recognized both by the National Archives of the United Kingdom as well as by us for his contributions to develop the significant advances to the pronoun droid signature set that is used world over as, in some senses, the core information to support the robust identification of file types of digital records and electronic information. In the context of his advances, his novel approach today arguably contributes to a 50% increase in the signature set that is used the world over for identifying digital files. So in that respect, it's a privilege to welcome Bill back. So let me turn on my mic, let me go back over to my chair, and basically what we'll do is, Peter, you and I had the privilege of talking last week about the advances in your tools in the ISDA environment. And what I'd welcome doing is sharing with our guests a summary of some of the developments that you have going on in Champaign.
Yeah, thank you very much, Bob. Again, I am very pleased to be here, and it's really a pleasure to come to the National Archives. I see many familiar faces. Some of you have come to my previous presentations. Right now, actually, I feel like I'm on an Oprah show. The similarity is that I cannot use my PowerPoint slides. An Oprah show, you cannot use PowerPoint slides. And the similarity is that when you leave this presentation, you won't get a car. But to be on a more serious note, to talk about what we have done for the National Archives, we have been looking at several fundamental problems and we decided to take the proactive and the reactive approach. If you have come to some of our presentations, the reactive approach is really about dealing with the humongous amount of data that the National Archives is receiving today and trying to help you to deal with the day-to-day operation and address some of the basic problems. For example, file formats. That was one of the problems that we looked at. And the challenge with file formats, as Bill will talk about, is that first you have to identify the file format, but there is no way for you to preserve all the file formats that are out there. We published several reports about 3D file formats. We identify 140 plus file formats. We know that many companies always introduce new file formats, then they go out of business, and the format is not supported. So the fundamental question in our research was, can we come up with a way how you, as an archivist, could automatically convert files from file format A to file format B? Right? And it seems very trivial because you can always go out there and get some kind of software that does it for you. But if you deal with thousands or 16,000 file formats, I think that's the number that I was told is probably used in the federal government, then it's not a trivial task. Especially many of these tools are graphically user interface driven. You don't want to be sitting there and then manually clicking, import, save out, and then the next one. So what we have designed is more or less a solution that allows you to just give us all the file formats, drag and drop all your file formats to, let's say, a web page, and the outcome will be your converted file. This has two pieces. The first piece is you have to know which software to use in order to go from file format A to file format B. And for that, with the help of the National Archives students working at Rocket Center, we have a database of about 2,000 plus software packages where we have documented the import or input and export or save as file formats. And so now, when you are looking for a file format conversion, you can go to this repository, you type in your query, and you say, I want to go from JPEG image to TIFF, and it will tell you all the software packages that can do it for you. And sometimes, some of these conversions require multiple hops, which means that it's not a straightforward conversion. You have to use multiple software packages. We can report that to you. The next piece to this is really, can we do it automatically? So for example, we did some timing, and if we automate this file format conversion, and we use even graphical user interface driven software, it will take about 4 seconds on average. We did some benchmarking. If you do it manually, think of yourself clicking and loading every file format and doing that over millions of files. That's going to take much more. So we can improve your efficiency and productivity by automating this. And now we have a service that you can use, and more or less you can drag and drop your file, select the output file format. It will give you the file format that you desire. The third piece to this equation is really, I converted my file. I would like to know how much information has been lost. Every time we go from A to B, something might have gotten lost. So we are currently building a system, and we already have a prototype functioning, where we can compare the file before and after conversion. That problem is not trivial because, as you know, as an archivist, you might have different criteria on the information loss than a person from Hollywood or a person from manufacturing industry. We work with companies that really care about geometry. So when you look at the 3D files, Caterpillar, John Deere, all these automobile industry, these companies would care about geometry much more than about the texture, the appearance. If you go to Hollywood and you talk to Pixar and they give you a 3D file, they really care about the appearance. So different customers or different clients for us would require different way how to measure information loss, and therefore we have this more or less it's a library or catalog of measures that you can choose from, and then we do the comparison for you. And you can also give us a set of files and say, well, this is the set of files that I really will be working on. This is a sample set. Can you give me the information loss measure? And this can be propagated back to your understanding which software would be the best for you as an archivist to use for long-term preservation. Some software is of high quality and it will, will introduce very little information loss. But there are some software packages that are, not really of high quality. Those people don't know the specification. Or if you look at, let's say, step file format for 3D CAD models, that specification has 1,200 pages. Not everyone is going to implement all the components. So the quality of that software that does the conversion for you is also evaluated using these services. The question is, how can we make it useful to you, right? So we do the research, then we build a prototype. The prototype is running. We can advertise with the help of our colleagues here at the archives. But how could we really deliver that to you so eventually it makes a difference in your day-to-day operation? And from the computer science perspective, where I'm coming from, we can give you a desktop application. So everything that we do for the National Archives is open source. You can download it, install it on your desktop, and run it. But many times, you might not be allowed to do that. Maybe you don't have the right platform, the operating system. Maybe it requires some configuration. Maybe it's more convenient for you just to go to a website, and we are running a web service for you. And then on that web service, you can call and then use it for your own purposes. So therefore, we have these online web services that you can use. And the third option is really, everybody has heard about cloud computing, right? It's a buzzword currently. And as you know, cloud is kind of a nebulous thing. You don't really know what to expect from the cloud. But it could be your storage, right? Cloud could be viewed as a storage media, but it could be also viewed as a media where you can do computation. So we actually designed a system in such a way that if you have very large volume of data that you need to convert, we can easily go and add many more machines on the back end for you, and then everything scales and it happens for you in the cloud. And if you deal with private, some private information or proprietary information or classified information, we can always deploy the cloud at the National Archives. The question is, and I was going to talk to Mike, the CTO of NARA, how that could happen. How would the National Archives work with you to support that activity? The second part, I'll just briefly mention that since the reactive approach to some of the problems that I have seen over the past 5 years at the National Archives is really, given these electronic records, very large number of electronic records, can you preserve all of them for no cost, right? That's typically your day-to-day operation task, right? No cost, preserve everything, do your best. So that is a hard problem. And therefore, we also took some of the approaches that we call proactive approaches. And those are approaches where you could go back to your superiors and say, well, if you are asking me to preserve all the information, this is how much it's going to cost. Because I have this understanding, this deep understanding, and a simulation model or forecasting tool that allows me to estimate how much it will cost if I have to preserve, let's say, we worked on a simple problem, which is decision-making in the government. If you are asked what should be the granularity of information that we preserve about decisions in the government, then clearly as you increase the granularity, you will generate more data. More data means you have to allocate more money for the storage, for the migration of the file formats, and for the migration of the files, because the storage devices are going to change. So is there any way how we could give you a simulation model or forecasting tool that allows you to understand the cost, or let's say the increase in memory requirements as you increase the granularity? So we built some very simple simulation framework. But clearly, the other approach would be to work with agencies that really care about the ISO standards, right? So if you can define a good data representation and everybody's going to follow that, then it makes your life easier. So just to summarize what we have been doing for the National Archives, these two fundamental approaches, the reactive approach and the proactive research approach we explored. But now our challenge is how do we go from all the innovation and the prototypes that we have built into something that you can use daily, and how do you kind of take the technology that we build, go through the technology transfer, and then move the prototype systems into production systems. And that question we have been exploring because in order to do that, the technology has to be robust, but also the clients or customers, or in this case it will be all of you, you have to show significant interest so there is enough justification to put money towards that goal. And what we have done over the past quarter, actually, we reported that to the National Archives. We have done several benchmarks, how much, let's say, how many file format conversions we can deliver per year. So let's suppose we estimated that if you take a virtual machine, which is, think of it like a machine, and you just assume that it's 50% up, right? 50%, you know, something has to be, there's maintenance, power outage, and so forth. And it has only, I think, one core, several gigabytes of, a couple of gigabytes RAM, and then I think 100 gigabytes of disk space. We can deliver about 1.5 million conversions on average. I'm not saying that it's some conversions take more time, some conversions take less. So now that might be a useful piece of information for someone who would like to deploy it because they know how much hardware they should buy, how much you know, the software, the licenses, and all these things. But we are kind of building the case for you. But in order for you to get the production system, we really need to see some engagement from the people that will be the users, and then make the justification to the funding agencies and to your superiors that these things are of interest. So I think that would be how I view our research and the impact of our research on your day-to-day operation.
Thank you, Peter. Maria, we had the chance to speak in March. And one of the things I would truly congratulate you on is all of the recognition that you've received since we last spoke. Particularly the aspect of having your work recognized as a national research highlight. As an archivist leading a cyber infrastructure project, what I'd welcome is the aspect of your perspectives, as an archivist, but also the aspects of the developments in your research at the Texas Advanced Computing Institute.
Okay, well, good morning. Yesterday, as I was coming to Washington, D.C. in the plane and waiting, I saw a lot of people with their laptops, and they were all, producing graphics, and that caught my attention. I guess I am in that business now. And then I also read the headlines in the newspaper that was saying that business analysts now look at tweets, they look at Twitter feeds, they mine Twitter feeds to understand what's going on in the world. And basically those two things put together, I can say in a nutshell that are, my goals as an archivist conducting research for the National Archives. First I will talk briefly about what we do at the Texas Advanced Computing Center, then I will talk a little bit about my perspective as an archivist conducting this research. At TAC, we look at large, TAC is a supercomputing center, just where Peter works as well. So we look at large data collections. We look at these large and multivariate data collections with purposes of archival processing, meaning appraising archives and processing them for access purposes and for long-term preservation purposes. So we take a testbed collection of millions of different files and different records and complex data objects, and we try to see the trends. So we use different data analysis and statistical methods, data mining, alignment algorithms, natural language processing tools. We also take information from tools like the ones that Dr. William Underwood is developing. We take classification methods that are being developed at the Library of Congress. And we use that on a relational database model. We mine and we query that data along with the data extracted from this testbed collection. And we look at those results in an interactive way through visualization. So the visualization is used for us to be able to understand patterns across different collections, to compare and contrast, and in that way to make decisions about how our collections are organized, what are their preservation needs and status, what is it that we do not know about the collection, and in order to establish priorities to be able to compare and contrast between these collections. So that's what we are looking at, general trends and patterns in collections, large-scale collections. In looking at that, we also look, as Peter said, at the machines, the resources, the networking, the technology, software, and hardware that we need in order to produce this service, this framework, this analysis framework. And so that's called cyber infrastructure. And so we understand what the future services or the services that archivists will need entail. What are the components? What are the pre-processing needs? What are the skills? And we present that in an interactive fashion. We do not think, as an archivist, I think that we cannot deal without both archival theory, concepts, and models, and without the domain expertise. And so we build tools that facilitate analysis in which the archivist really puts his knowledge, experience, analytical skills in identifying data points, identifying information points, and interacts with the visualization. We try to build a tool that will facilitate those analysis workflows, that will keep track of the analysis workflows, but where the input of the archivist in making inferences, in making conclusions is fundamental. And how those inferences and conclusions can be fed back to the system in order to then establish predictive models as, what this collection looks now. As an archivist, I have defined what a record type is, what the confirmation is, how it's organized, what preservation needs it has, and then that can be used as a learning tool to analyze future incoming collections. So we are trying to streamline the processes between computational analysis and archives expertise. In that process, in that research process, as an archivist, I am heavily involved, and I have moved from the model of the archivist being the requirement person, the one that says, I want the system to do this, that, and then steps back and receives a system that might not really fulfill the imagination or the expectation or the fantasies. So I am heavily involved in all of these different processes, in identifying problems, identifying tools and methods that can be used, in working throughout the research process and understanding that sometimes the methods are not adequate, in evaluating and interpreting those results, and moving on towards development and making decisions about what the methodology, what the final tool or the final framework needs to look like. We have to be in terms of using visualizations and in terms of using classification systems and data mining and other data analysis methods. I have to be looking at how we represent collections visually, whether those representations make sense, whether the information becomes too overwhelming, even visually, to be understood. What information, as archivists, we're very, very much in tune to understand from massive collections what are the data points that users might need, not only to access the information that they need, but to also interpret it in context and to preserve, the authenticity of the information. So all of that experience I give to my work and my everyday work. as an archivist. I constantly look into how archival methods and theories fit into my research. So far, I have found that all our concepts, all of our traditional concepts of archival bond and context and structure and original order and provenance, they are still relevant. They're very relevant to my work. It's just that the methods have changed the ways and have made our work more exciting and more flexible. We can establish correlations that we never thought we could before. We can establish relationships across different collections, across different data sets of different sorts in ways that we wouldn't have been able to do before. We can infer how collections are organized using natural language processing methods so that we don't need to be counting or looking or reading. We can use all these new concepts that are distant reading, Google reading, and we can be as precise. We ought to be as precise as we have always been, but we can also get these overviews of the collection, and which facilitates our understanding of the amount of information and the huge amount of information that we are taking care of. In my work, I normally use a lot of colleagues to come and test the visualizations, to come and look at the visualizations, to give me feedback. We work in focus groups, we developed a preservation appraisal visualization, and again, we worked in focus groups with 2 preservation librarians and archivists. But I highly recommend that you get involved in this research as well, because it's not only fascinating, but it's also crucial that you participate. Otherwise, the research becomes very distant. And I agree also with Peter, then the gap between us conducting research and doing tools and their implementation as an infrastructure here at the archives becomes very, very removed. I think I have addressed, my case study. As I said, what we are looking at is trends in large data sets to understand their composition, to understand how they're organized, and to understand to interpret the characterization information, which is the file format identification information, and how data objects, complex data objects, are formed and organized. We also look at large-scale problems with email. We use cloud computing to analyze on the cloud, although we know what the cloud is. But we use the same technologies that Google is using. In fact, we use open source tools that they have developed, Hadoop and MapReduce, and to understand from large email collections what are the stories. Our goal is to be able to establish what the finding aid and how these analyses map to what we think, what we understand as a finding aid. And we are now recently also looking at other types of news and press releases. But again, this research only makes sense in large scale. We're not looking at small piecemeal amounts of documents. It's based a lot on the characteristics of the work that we do, on how we archivists analyze collections, how we look at structure of collections, how we look at describing the collections, how we look at documents, what are the characteristics of emails to us, what are the characteristics of government records, and in what conforms a record. That's a discussion that we always have with Mark Conrad. What is a record? Is a website a record? Is a web page a record? We have collections that span from business reports to federal government classified information to data sets. There's the National Archives has a lot of data sets, scientific data sets that they will have to preserve, GIS data, environmental data, FDA data. And so what constitutes the record and whether we can visually identify what constitutes a record, the relationships between these records based on their composition, on their file format, on the way that people have decided to organize them, or their functional properties. So a GIS group of files will not function if they're not organized in a specific way. The software won't read it. So can we detect what is that confirmation? A 3D model also has a lot of components, and what is the complete record that forms a 3D model, et cetera, et cetera. So if anybody's interested, I can show you some movies that I brought from the visualizations, but basically my point here was more to talk about, as an archivist, how I view this research and how I think it helps, or it will help you make decisions and preserve and give access to these records for the long term.
Thank you, Maria. And again, congratulations. Bill, there's no surprise. You're next. The aspect of your work with computational linguistics, file type identifiers, tools, record type developments, the aspect of tools that can detect the presence of sensitive information elements in commingled collections. I welcome your perspectives.
Thank you, Bob. Okay. See where to jump in. I'll start off with the work that Bob mentioned having to do with file format identification and place that in context. As archivist, you're probably well aware for digital records that you need to be able to identify the kinds of records that are coming into the archives so that you know whether or not you can preserve them and make them available to the public. And identify, if necessary, as Peter is looking at, what technologies might be necessary for converting them to standard formats that you are able to preserve and over the long term. Also to have viewers for those, or players for them available. And so having, actually in some early work that I did for the National Archives in assisting archivists at the Bush Presidential Library in College Station, Texas, we found the need to identify personal computer files from the first President Bush administration. And so their only identifier technology that was available at that time was the file command and magic technology that's available with Unix and Linux. But it had some shortcomings. In particular, it did not address personal computer files extensively, but was focused on Unix types of files. And furthermore, it was not all that reliable. The development of the technology was not systematic. So we set about trying to be more systematic about defining tests for the file signatures of file formats. And over the last decade, we've developed a signature tests for approaching 900 file types that extend back to the middle 80s and up to the present day. And we put these into a library where we've also collected viewers and players for those files and references to file format specifications when they're available. And also we're collecting samples of those file formats. And to this end, we've been collaborating with the National Archives laboratory that's up at Rocket Center. And Mark Conrad has been leading some students who've been a major aid in looking through the internet to find federal records that we might be able to use as samples of these file formats, and also then make them available to others for their testing purposes. Also to identify file format specifications. We've also had to, or we're focused on making improvements to the identification technology that's involved in the file command. It has some shortcomings that make it difficult to identify some file types. Along the way, Bob here indicated that we should be collaborating with the National Archives of the United Kingdom, who had set up the Pronom registry and was developing another technology for file format identification that was based essentially on regular expressions for describing the internal signatures of file formats. And while they had registered something like 700 file formats, they only had internal signatures for about 150 to 200 of those file formats. The others were still being identified by file format extension. So we looked at, it turned out there was a significant overlap of the research that we'd done with the files that were in their registry. So we've started converting the magic notation that's used with the file command into the regular expression notation that's in the Pronom registry and that's used with the Droid file format identifier. And we've contributed over 100 internal signatures, proposed signatures, and we're in the process of creating signatures for another 50 that we'll be sending soon to TNA. And it's very much I will say, a collaborative effort where we propose something and they look over the signatures and test them and indicate if they feel there are some modifications that need to be made. But I think we're coming up with a really good, significant set of tests that in the future you'll be able to rely even more on the Droid file type identifier. As far as the file command and the magic file is concerned, the file command is open software. And so at some time in the future we'll be plan to contribute the work that we've done improving the magic file for the file command back into the Linux community. Okay, and a lot of the research that we've done over the last dozen years or so with the support of the National Archives has been in support of automatic description of record series and of file units or individual records in record series, and on attempts to improve the precision and recall of information retrieval tools or of access to large collections of records. And then thirdly, to also look at enhancements that can be made to the decision support for the review process in response to FOIA requests. And the technologies that we're primarily applying there are from the discipline commonly known as computational linguistics or natural language processing. And one of the simpler, actually, technologies in that domain is a technology that was initially developed under DARPA's support and the message understanding conferences that's known as information extraction. And essentially what this is doing is identifying the semantic categories of proper nouns in text. So the goal was to identify persons' names, proper nouns, locations, proper nouns, location names, organization names, other dates. And then in addition, they've extended that to, in the ACE competitions and such, to look at relations of concepts and such. And we recognize the need to do this in support of improving information, record access, and FOIA review and automatic description. So we started off with an existing technology that was available from the University of Sheffield. Some tools that are available in something called General Architecture for Text Engineering, and a particular tool that was for information extraction in English. This is available on the internet. You can download it. But we did, and we applied it to some actual personal computer records from the first Bush administration. And we found that its performance was less than 80%, let's say, more like 75%. So the vanilla version that's available was not really a practical tool, but it provided a framework for development. And so we spent really a couple of years improving the resources that were used in GATE and increased the performance of those tools to where the precision and recall and so-called F measure were better than 0.90. And they're actually better than that now. They're up more towards 0.92, 0.93. Having done that, that's really the basis for what we need to do. And one of the ways we use that is to develop a method for automatically identifying document types or documentary forms. So in XML, which things that are called document type definitions are a formal definition of the style of a document or the intellectual elements of that document. But for traditional documents without XML technologies, you just have text, and you have it, furthermore, in different file formats. So we build a prototype which converts, first of all, we identify the file format using our file format identifier, then convert it either into text or into HTML. Then we apply the information extraction technology to mark up persons' names, dates, organizations. We extended it to addresses, for instance. And what we're doing is identifying what in the field of diplomatics and also in archival science are called the intellectual elements of the form of this document. And we, first of all, manually constructed context-free grammars for the structure of about 15 document types. And the terminals of those grammars are the intellectual elements. There are things like the date, the person's name, job positions for letters, indications of subjects and topics in memos. And anyway, we ran some experiments to demonstrate that we could automatically identify document types. And one of the major experiments was to take the contents of an actual personal computer from the Bush administration. It really only had about 150 to 200 files in it, but we were just from that able to convert whatever was there into text format, apply the grammars, and to identify the document types. Now, the value of identifying the document types, among other things, we can use them in description, but it also allows us to extract metadata from the documents. So now, for many of the documents, we can say who the author is, who the addressee is, what the date is, and in the cases of memos or reports and such, we can also say what the topic of that particular record is. So we have some of the first steps toward automatic description of items. So for some of the items, we are now able to say, this is a memo from so-and-so to so-and-so on such and such a date about this topic. Having done this for items, the idea is to do that for the contents of file units, to generalize it, and then to generalize the descriptions for file units to the descriptions of series. In the case of, we have started to construct something we called an access restriction checker, which could be in the future, it's just an evolving prototype at the present, could be a tool in support of FOIA review. Not to replace the archivist, because they have the responsibility for making the decisions having to do with FOIA review, but to check their work or to support the training of archivists who were just beginning the process of doing something like FOIA review. Well, so how does it help? Because it turns out that in the Presidential Records Act, for instance, there are certain restrictions on disclosure that have to do with advice to the president. It's a small piece, but I'll stop there.
Thank you, Bill.
Yeah.
Thank you, Maria. Thank you, Peter. Again, I'm Bob Chaddock, and as Rita, in the context of even after 3 days, after you have a new administration as the Assembly President, just tell us your perceptions of the value of this hour.